Hello, everyone. We're going to talk about annuities today. So, what is an annuity? Annuity is a series of payments made at specified intervals for a fixed or a contingent period. We're going to start with a simple case, which is a fixed period. Uh, the first concept is annuity immediate. This is an annuity that lasts n interest periods with payments at the end of each interest period. So it's the end of each interest period. So that's uh, the important part. Later on, we will have an annuity due, which is at the beginning. The payment is paid at the beginning of each period. So immediate signifies of or near the future time. So it's actually not right away, which means the starting point of each interest period. It's actually the end of interest period. A basic annuity immediate is an annuity immediate with level payments, each of which is equal to 1. So if you wanted to draw a timeline, so basically you would have something like just time 0, you have 1, you have 2, and dot, 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 then you have n, and you pay 1, 1, 1, the end of each time periods. All right, so let's introduce the notation and the formula. So the annuity immediate, a basic annuity immediate, which is this thing, its present value is denoted by A sub n angle I. Okay. It reads the present value of the basic annuity. So how can we find the formula? The formula is basically you discount each $1 back to time 0 and you add them up. So for this one, the first payment, you will have just 1 plus I to the negative 1. That's V, right? And for the second, for this payment, the present value is 1 plus I to the negative 2, which is V squared. And the last one, you move back, this is 1 plus I to the negative N, which is V to the N. So this present value is simply the summation of these present values. And these are the present values for all the payments. And it's a geometric series. So we move out 1, we move out V, then you have 1 plus V plus dot 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 plus V to the N minus 1. And the formula is V times 1 minus V to the N over V. Okay. Actually 1 minus V, sorry. It's the formula for general geometric series is that 1 minus R to the N plus 1 over 1 minus R. Okay. You have N here, you have N plus 1 here. Okay. So let's simplify a little bit. 1 minus V is what? Is the V equals 1 over 1 plus I. So 1 minus V equals 1 plus I with over 1 plus I, that's 1, and then minus 1 over 1 plus I, that is I over 1 plus I, okay? but then you multiply by v, right? This is on the bottom. This is 1 minus v. So v divided by 1 minus v, that equals v is what? V is 1 plus I to the negative 1 times, you flip it, I on the bottom, you have 1 plus I, you cancel out, you just have 1 over I. So the formula is this, okay? 1 minus v to the n divided by I. The formula I like to use is this 1 minus 1 plus I to the negative n over I. So this is A sub n angle I. Okay. Some more elementary financial math course has this kind of formula. For example, finite math has this formula. But 1 plus I to the negative 1 is just v to the n. So it's really equivalent. So this is the present value. Now another concept, actually it's just a notation, is the future value of this annuity. It's denoted by S sub n angle I. It reads as S angle n at interest rate I. That's how it's read. But when I write, I normally write, when I say it, it's S n angle I. Okay, that's it's probably not standard, but I think it should be okay. All right, so what you do is you accumulate. Instead of a discount back to time 0, you have a future value of all these. So be careful for this payment of $1, you would accumulate to 1 plus I to the n minus 1. Okay. And then the second one, because it's from 1 to n, you actually have n minus 1 periods. And then you have 1 plus I to the n minus 1 plus dot 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 plus 1. Okay. So this is actually not correct. It should be n minus 1. It should be n minus 1. And now you do the similar thing. It's a geometric series. You can rewrite it something like 1 plus 1 plus I plus dot 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 plus 1 plus I to the n minus 1. So that is 1. We can do 1 plus I to the n minus 1 over 1 plus I minus 1. We originally have this thing. That is 1 minus r to the n over 1 minus r, okay? I freely do n minus 1 and n, it doesn't really matter. It's a formula, so as long as you understand this n is 1 plus this exponent. Okay, but that's the same as r to the n minus 1 over r minus 1. It's obvious. Obviously, they are the same. When r is greater than 1, sometimes I prefer this thing, but it's not really, doesn't matter too much. So the bottom is I, and the numerator is 1 plus I to the n minus 1. Okay, so we have these formulas. Okay, this is 1 minus 1 plus I to the n over I, while the accumulated value, the future value, also accumulated value, is 1 plus I to the n minus 1 over I. Okay. You should notice that Oh, I actually made a mistake because I wanted to, not because I wanted to, because I found that something I wanted to emphasize, and I realized there's a mistake here. It should be negative n. Okay, it's not n. So you have 1 plus I, which is greater than 1. And you take you raise the power by negative n, and so it becomes less than 1. And 1 minus that number should be positive. While 1 plus I to the n is greater than 1, and minus 1 is okay, it's positive. Okay, so the previous the expression I wrote earlier, 1 minus 1 plus I to the n, obviously it would be less than 0, so that's not good. Okay, so I hope that helped you a little bit to when you try to memorize these formulas. Okay, so the relation between the present value and the future value obviously is the following. So S n angle I equals A sub n angle I times 1 plus I to the n. Okay, it's very easy to show by algebra, but I wanted to emphasize that these three things, when I is fixed, we would consider them to be equivalent. So these three things, this quantity, okay, this value, it's a value, and this is another value, it's a future value, and the previous one is present value. And then you have the whole annuity. So these three things are financially equivalent. Okay. All right. Next. So are we just working on the examples? I think so. All right. If the payment is not 1, you just multiply by payment. I use P. I think the textbook uses Q, capital Q. I use little p. So not A. It's the present value that's normally I write. So the present value equals P times 1 minus 1 plus I to the negative n over I, which is P times A sub n angle I. And the future value is P times 1 plus I to the n minus 1 over I. That's P times S sub n angle I. Oh, by the way, these notations you should be very familiar with and use them freely. All right, so let's look at this example. Find the present value of $5,000 paid at the end of each year for 15 years. So we have n equals 15. I is 0.075. It's annual, so we're fine. We don't need to do conversion. So we're looking for the present value at the beginning. So PV equals 5,000 times A sub n 15 angle I 0.07, which is 5,000 times 1 minus 1 plus 0.075 to the negative 15 over 0.075. And I calculate it. That is in the yeah, it's 4413.6. Okay, so that's the present value. All right, with a dollar sign. The future value, you can do two ways. You can do this 5,000 times S sub n, which is 15 angle 0.075. So that's 5,000 times 1 plus 0.075 to the 15 minus 1 over 0.075. So that is 130,591.82. Okay. All right. You can also do this. The future value equals the present value times 1.075 to the 15. Then you will get the same answer. Okay, so, all right. Next question. John wishes to borrow 4,400 2-year loan with monthly effective rate 0.25%. Find the level payment. Okay. This is monthly rate. Be very careful. It's not annual rate. So it's kind of J. Okay, so this is the present value. Okay, the loan amount usually it's the present value. So 4400 equals the level payment. We need to look for that. We're looking for that. And it's A sub N is how 2 years, 24 months with monthly rate 0.0025. So P equals 4400 over A sub 24 equals 0.0025. And you use this formula, right? This formula, flip it. I have a 4400 times I 0.0025 over 1 minus 1 plus 0.02, so again 25 to the negative 24. All right. That is 189.117332. So you're gonna raise it to 189.12. That's the level payment. So the answer is the same number, but the last payment is $189.05. The reason is that you pay this each month, and then you pay a little bit more, about 0.2668 cents. And they're gonna accumulate it. So the last payment will be a little bit smaller than the level payment. Okay, so that's this one. To find that, you can do this. You can do to find the you find the accumulated value. You use this S 24 0.0025. So this is the future value when you pay that, but you pay more than T. Actually, it's a little bit tedious, I guess. I don't know what to say. 4400 times 1.0025 to the 24. That's the accumulated value for the loan. So this is not annuity, okay? This is not annuity formula. So this is discrepancy, and then you subtract that from 189.12. You will get that. Okay. All right. Next problem. Mr. Leon wishes to accumulate $200,000 for his daughter in 18 years. D equals 5%. Find the level payment in the end of each year. So it's an annuity immediate. This is the accumulated value, which is the future value. So we set up this equation as 200,000 equals P times 1 plus I to the 18 minus 1 over I. we're given D, so we need to find I. So we use 1 plus I times 1 minus D equals 1. And we would get I equals D over 1 minus D. All right. So P equals 200,000 times I over 1 plus I to the 18 minus 1. And that equals 200,000 times I, which is D over 1 minus D, so 0.05 over 0.95. 0.95 is 1 minus D. Here, 1 plus I to the 18, I'm going to just do this directly. So 1 plus I to the 18 should be equal to 1 minus D to the negative 18. Okay, basically you raise this equation by a power of 18. So I can do this 0.05 directly, and then you have negative 18, okay, and minus 1. This number is less than 1. You take the negative power, it actually is bigger than 1, so minus 1 is positive. All right, we calculate it out. What is that value? That's 6,936.4676. So it's kind of a 47 cents. All right, so that's this problem. Next one. Jack contributes $100 at the end of each month, wishes to accumulate $3,000. So this is the future value, okay? At which time he will buy a piano. And I to the sup parenthesis 12, this is the nominal rate, 0.054. So the monthly rate is simply divide this by 12, so that's 0.0045. Okay. So let's convertible monthly, so you divide by 12, okay? You divide the nominal rate by 12 to get the monthly effective rate. You do not divide the annual effective rate by 12 to get the monthly effective rate. Instead, you need to go through this equation. Yeah, this is the effective rate, but here is the nominal rate. So you just divide that by 12. We're looking for the number of months. So accumulated, so $3,000 equals $100 at the end of each month for S. N is what we are looking for, and we have J 0.0045. So I have 30 equals 1 plus 0.0045 to the N minus 1 over 0.0045. So you would have a 30 times 0.0045, the plus 1, that equals 1.0045 to the N. And what is that value? It's you find this value and then take log on both sides, and you would get N equals 28.203858 months. So normally we round up. The reason we round up is that we wanted to accumulate at least $3,000. If you round down and you have only 28 months, then the money is not, the accumulated money is not, it's smaller than $3,000, which is not what we want. So normally we round up. We want to overshoot, but not undershoot. Okay, so the answer, you could answer it as 28.2 or 29. All right, either way is okay. If the question asks you to give the exact number of months, probably 28.2 is better. But if you want to get integer number of months, then 29. Okay, example 5. John invests $500 into an account at the end of each month for 5 years. The annual effective interest rate is 4.5 percent. Calculate the balance of this account at the end of 5 years. Okay, so this is the annual rate. 5 years, that's 60. 5 times 12 equals 60 months. So we are looking for the future value, okay, because that's the balance in the end at the end of 5 years. So future value equals $500. That's the monthly payment. And you have S 60, and then you have J. Okay, so that's the formula. And we have a 500 times 1 plus J to the 60 minus 1 over J. To find J, we have this formula. J equals 1 plus I to the 1 over 12, okay, minus 1. Okay, 1 plus J raised the power by 12, you get 1 plus I. I is the annual effective rate. Okay, so I have 500 here. J is what? 1.045 to the 1 over 12 minus 1. So that's our J. 1 plus J to the 60, it's actually, you can simplify this expression by doing 1 plus I to the fifth. Again, it's actually the same because 1 plus J to the 12 equals 1 plus I. Okay, so it's just like using annual effective rate for 5 years. So that's the equivalent. All right, so I have a 1 plus I, which is 0.045 annual rate, 5 years. All right, so you would get some value. $3,495.88. All right, next problem. A cash flow pays $8,000 at the end of every other year, so 2 years, okay, for 16 years. So n is actually 8 because you have a you have a payment each 2 years, once in 2 years. The first payment is made in 2 years, so we have annuity immediate. The annual effective interest rate, I, is 0.065. So in order to get J, you need to do 1 plus 0.065 squared minus 1. Calculate the present value of this cash flow. So we have present value equals $8,000 per 2 year. 1 plus, not 1 minus actually. 1 minus 1 plus J to the negative 8 over J. So that's 8,000 times 1 minus 1 plus J to the negative 8. That is the same as 1 plus I to the negative 16. Okay. Again, if you plug in 1 plus j to the negative 8, and you replace 1 plus j by 1 plus I squared, and you would get this term, so that's no problem. And then j, I have to do 1.065 squared minus 1. All right, and I would get 37,841 and 217. 217, that's 22. And so that's the and so that's the answer. This is annuity immediate. The next section we're going to talk about annuity due, but for the moment, I'm going to stop and continue in another video. Okay, I'll see you later. Bye bye.